Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we will be continuing our look at various objects in the solar system. We will be continuing with dwarf planets. There is the comet C2023A3 still there, just barely visible as we come to the end of October. We will be moving out into the countryside, but before we do, the target of observation for this show is the dwarf planet Eris. Dwarf planets are often a little bit more eccentric or more highly inclined than the planets. So we're not guaranteed to get dwarf planets along the line of the ecliptic. Eris at the moment is thankfully pretty close. There it is. So Eris is in between Jupiter and Saturn. It's in this region of the sky that looks pretty empty if you're looking at it from the city. And we will stick with the city for now, at least, before moving into the countryside. Looks like it's in the constellation of Cetus, just over here. So Eris is the dwarf planet. Eris was the object that motivated the reclassification of planets and dwarf planets, the reclassification of Pluto. So Eris is a little bit smaller than Pluto when it comes to diameter. I wonder if diameter is listed over here. Yeah, 2,600 kilometers. So not particularly big. If you imagine cutting out Russia or maybe the continent of South America from the Earth's crust and folding it into a ball, that's the kind of area we're looking at here. So they are incredibly small objects. But Eris is a little bit more massive than Pluto. Because it's massive but smaller, it means it's more dense, it is more tightly aggregated. So this is definitely a solid ball of rock. And we can see its distance here from the Sun, 95 AU. Almost 100 times further from the Sun than we are. Now, 95 isn't exactly 100, but rounding up. Eris is incredibly distant from the Sun. And of course, it takes a very long time to orbit the Sun. We're seeing a sidereal period here of 500 years, 556 years. Hundreds and hundreds of years for Eris to orbit the Sun. Eris is here at 18.72 magnitude, which makes Eris, of course, impossible to see with the naked eye, but very difficult to see even with telescopes. We're going to head out into the countryside now, which will make things better. We will get a slightly better view of Eris from the countryside, but it's still going to be incredibly difficult to observe. So let's head out to the countryside. Here we go. So Eris was discovered by comparing the little bright dot we're seeing to the background stars. Now, it doesn't look like we're seeing any background stars behind Eris here. Presumably they would be too faint. Removing the atmosphere doesn't even bring any extra stars into view. But there are more stars out here, and by watching Ceres over the course of, I believe it was originally just a few hours, but if we watch Ceres over the course of, or Eris, if we watch Eris over the course of a couple of days, we can see that it's definitely moving compared to the background work of the stars. It's definitely orbiting the Sun. We can see there an asteroid that's much closer to the Sun, moving way faster, zipping across the sky. But Eris there, it might be slow, it might be gradual, but it is moving around the Sun. This is our view of Eris in the countryside with a massive telescope, Meade LX200, 16 inches wide across the top. So this is an LX200 is a Schmidt-Cassegrain reflecting telescope, a modified reflecting telescope. So not particularly long, but incredibly wide. We've got oculars here to help to increase our focus, our cutting down on the amount of sky that we can see, and it's got a 3 times Barlow lens to make it even more visible. Even with a telescope this massive, if we didn't have the help of those lenses, it would barely be visible at all. And if we were using a different eyepiece to try and get a wider view of the sky, that could also make Eris completely invisible. Those astrometric guidelines almost block it out because it's such a tiny dot. That, yeah, is the biggest telescope that Stellarium will simulate. So that'll give you an idea of how massive a telescope like this is. Going with even a slightly smaller telescope, going down there to one of the less wide ones and getting rid of one of the Barlow lenses, both of them, and Eris is invisible. This is with a telescope 10 inches across. So just to give a quick comparison, Eris is invisible using a telescope that would let you see Jupiter, or let's say Saturn, like this. all of the moons, all of those details, even quite small objects, nice and clearly visible. And if we're looking at Eris, it's not visible at all, even with a telescope that large. So Eris was incredibly difficult to spot. It took a lot of observation, and it took people deliberately hunting for something after Pluto, which of course they were. Pluto was discovered because Neptune's orbit seemed a little bit strange. Oh, that's Eris. So that's the closest dwarf planet to us, and a dwarf planet that is technically visible through binoculars and telescopes. You can see Ceres without using a crazy big telescope, whereas Eris is completely out of view, unless you're a small observatory yourself. As I was saying, Neptune was discovered because Uranus's orbit was a little bit strange. People were looking for something big outside Uranus that could help explain the strangeness of its orbit, so they found Pluto, or they found Neptune. Neptune's orbit was also a little bit strange, so people kept looking. They found Pluto. But Pluto was too small to explain the changes in Neptune's orbit, so people kept looking, and they found Eris. They also found Sedna and a bunch of other objects. Some other dwarf planets and distant objects were discovered before Eris, but it was Eris's mass. Its size was so close to Pluto's, and the fact that it was discovered to be more massive, this let people know that something was going to have to change. We were either going up to 10 planets in the solar system, with the outer ones being tiny, or we would need some other definition. And with big round objects like Ceres and other discoveries coming in so rapidly at this time. So yeah, we can see where was its discovery isn't listed, but it was recent. The discovery of Eris was quite recent in comparison to the other objects in our solar system like Pluto. But when Eris was being discovered, the astronomers knew that it was going to shake things up, which is one of the reasons it was called Eris. Eris was the goddess of strife and discord. The inability to communicate, of course, being where the term discord comes from. Dysnomia does not seem to be included. Dysnomia is, however, the moon of Eris. So Eris has a moon orbiting around it, and a lot of these small dwarf planets do have moons. Of course, being way out towards the Oort cloud and the Kuiper belt, there's a lot of small objects flying around. There's a lot of objects out there that haven't been consolidated into planets. So, Pluto has a bunch of moons. A lot of these smaller objects have moons, often many of them, even though much larger objects that are closer to the sun, like Mercury, have none. There's less available little bits of rock. There's less available free objects to grab in here in the inner solar system, whereas way out in the outer solar system, there's a lot of different objects flying around. So we're looking just in here. And of course, if you've got a massive telescope, you might be able to see Eris, but your telescope has to be fantastically large to see these incredibly distant objects. We're going to head out to the Solar System Observer again. I didn't do it in the last video, so I might as well do it again here, and that is not how I do it. Just to give a rough idea of how far away Eris is, and we might be able to take a look at it flying around the sun a little bit as well. Here we go. Solar System Observer. And we'll find Eris. Won't even have to zoom out for Eris to be visible. It is a pity that Dysnomia isn't visible. It's a tiny little moon orbiting Eris. Of course, it would have to be pretty small. So here we go. There's the sun. And let's bring up the orbit just to... Yeah, we'll make it only for the selected object. Here we go. So there's Eris. There's its orbit around the sun. If we try and get the sun in the center, you can see that it is not a crazy eccentric orbit, but it is a little eccentric. It does seem a little bit off center, and it is also reasonably inclined with regards to the ecliptic. Moving through, any small amount of time here, we're not going to see much of a difference, but I'll see if I can move through years instead. So here we go. There is Eris, and if we start moving through years, we can see the inner planets looping around the sun really quickly, and Eris just inching away along its orbit. Of course, as I said, it takes hundreds of years, so it would take a lot of time changes for Eris to noticeably move. But we can see it's creeping along that line just a little bit, nice and slowly, and its distance to the sun is changing, and its distance to us is changing as well. You can see it's down to 90 AU from us, 92 AU from the sun, and so that will keep changing as we go through the years. Of course, thanks to our orbit, our distance to Eris will change by about 2 AU. We'll be 2 AU further away from it, or we'll be an AU further away from it when we're on the far side of the sun, and an AU closer to it when we're on the near side of the sun. So a change there of 2 AU depending on the time of year. And we can see there it's now closer to the sun than it is to us, so presumably on the far side of the sun from us. But we can see that those numbers, they indicate a bigger difference than just 2 AU, and part of that is due to the inclination as well. So Eris could be way above us on the plane of the ecliptic or way below us on the plane of the ecliptic, and that will influence its distance to us. Of course, that'll make it a different distance away. We're way back in the 1700s here, and we've barely gone through a quarter of Eris's year. Let's bring that back up to 2024. There we go. Yeah, way back up to there. So that's Eris. Eris is the dwarf planet that's caused all of the issues. It's the reason why dwarf planets are a thing. We discovered Eris and we realized Eris and Pluto have a lot more in common with each other than they do with the rest of the objects in our solar system. So I hope you enjoyed this little look at the cause of so much strife and discord. I hope you enjoyed this video. If you did, please do like it. You can also subscribe to my YouTube channel to support future videos, and you can read a little bit of this information on my website, queebeanscontent.ie. Hopefully, I'll see you back here next time.